From ancient times, people were aware of geometry and used it in their day-to-day life. Let's take an example of ancient Egypt. After the flood, the boundaries of lands would dissolve away. So nobody would know which part of the land belonged to whom, and this would result in confusion. As this was an annual problem, they came up with a system of measuring land and redistributing it to the respective owners after the flood. This system of measuring was one of the factors that gave birth to the word geometry, which we study today. The Indus Valley civilization around the year 3000 BCE also made use of geometry. Their cities were well planned, houses had different types of rooms, well-planned roads, and a good drainage system. This was not possible if they did not know the use of geometry. Basically, geometry was being used in many parts of the world throughout the period. The word geometry itself comes from the combination of Greek words geo meaning land or earth and metrine meaning measurement. So geometry means the measurement of earth. The geometry we study on paper today was actually conceived as a solution for day-to-day problems in the ancient world. The ancient Egyptians also used geometry in construction, designing granaries, and making the pyramids. So, all the existing knowledge about geometry was brought together in a form of books by Euclid. Euclid was a Greek mathematician who used to teach mathematics in the city of Alexandria in Egypt. He was the first person to collect all the work done on geometry and put it together in books called Elements. His books contain definitions, axioms, postulates, and proofs that we can use to prove things further ahead in complex geometry. We will try to cover some important definitions, axioms, and postulates from his books that will help us in solving and proving theorems to make our understanding of geometry clearer. In this lesson, we will understand some basic definitions in geometry. The first definition is that of a point. Euclid defined a point like this. A point is that which has no part. In simple words, a point is the smallest and the most fundamental aspect of geometry. It has no size, length, or depth. It's shown by a dot. Everything we will learn from now on will be based on a point. So let's do one thing. Let's place similar points closely one after the other. We see that it appears as a line. So, a line is basically a closely spaced collection of points one after the other. Euclid defined a line like this. A line is a breadthless length. As we can see that the line has length but not breadth. Since a line is just a closely spaced collection of points, we can see here that the ends of a line are also points. Euclid defined a straight line as: a straight line is a line that lies evenly with the points on itself. We can understand this by taking a look at our line. Here, we observe that the arrangement or the alignment of points before this point is similar to the arrangement of points after this point. This pattern can be observed uniformly throughout our line. Thus, by Euclid's definition, it's a straight line. Now, let's place a series of similar lines besides our line. When we do that, we see that the resultant pattern covers an area and has a length as well as a breadth. This is the geometric definition for a surface. Euclid defined surface in the following way. A surface is that which has length and breadth only. If we look closely at the edges of the surface, we will find that the boundaries of the surface are nothing but lines. So we can say that the edges of a surface are lines. Now let's look at the surface from the side view angle such that only the edge of the surface is visible to us. When we do that, the surface appears to us like a line. By Euclid's definition of a straight line, if the points on a line are evenly spaced, then it will be a straight line, which means the edge is a straight line, and the surface will look flat like this. Such surfaces where the straight lines are evenly placed are called plane surfaces. Euclid defines a plane surface like this. A plane surface is a surface which lies evenly with the straight lines on itself. Some examples of planar surfaces are a blackboard, a tabletop, plane mirror, and so on. If you look at all the 7 definitions, you will notice that these are the basic definitions that will form the base of our geometry. After explaining definitions from his book Elements, Euclid went on to explain some axioms that would help in understanding geometry better. What are axioms, you may ask? The general meaning of an axiom is a statement that is universally true and needs no proof. For example, we all know that most humans have one brain. We just know it's true and must be accepted. Similarly, Euclid assumed that some properties were true and did not have to be proved. He called these truths as axioms. These axioms are not restricted to geometry and can be applicable throughout mathematics. They will help us to prove and understand complex geometry in the upcoming lessons. In this lesson, we will study some of his axioms. The first axiom is, things which are equal to the same thing are equal to one another. What does this mean? Let's understand with an example. Suppose Bob and Rob go to a store and both of them have 5 rupees. Bob buys a pen for 5 rupees and for the same price, Rob buys 2 candies. This means that the cost of 1 pen is equal to the cost of 2 candies. So if later Rob wants to trade his candies for Bob's pen, he would have to give 2 candies to Bob. This means the value of 1 pen is equal to the value of 2 candies. In mathematical sense, if a quantity A is equal to B and B is equal to C, then A is equal to C. The second axiom states that if equals are added to equals, then wholes are equals. To understand this axiom in a simpler way, imagine if for 5 rupees you get 2 candies and for 7 rupees you get 1 pen. So if you add them together, you will see that for a total of 12 rupees, you will get 2 candies and 1 pen. In the mathematical sense, let's say a quantity A is equal to C and quantity B is equal to D. Then A plus B will be equal to C plus D. The third axiom says that if equals are subtracted from equals, then the remainders are equal. Similar to the second axiom, if a quantity A is equal to C and quantity B is equal to D, then A minus B will be equal to C minus D. We will explain the remaining 4 axioms in the next part of the video. Can you construct an equilateral triangle from a line segment AB? Think about how you can do it. To construct the equilateral triangle, we have to find the third vertex other than A and B. For that, let's take a compass. We put the fixed point of compass on one of the points, say B. Now taking this line segment AB as the radius, we draw a circle with B as its center. Similarly, without changing the length of the compass, repeat the process by placing its fixed point on point A. Now we see that we have 2 circles with centers A and B, and both these circles intersect at these 2 points. So if we join points A and B to this point, we see that they are nothing but the radii of the circles. And since the radii of both the circles are equal to each other and also equal to the length of side AB, we get an equilateral triangle here. We will get an equilateral triangle even if we join points A and B to this point here. Wasn't it interesting? Such knowledge of geometry was known to people from ancient times. Around 300 BCE, the Greek mathematician Euclid combined all the knowledge of geometry known at that time in a set of 13 books called Elements. He called these true statements or facts as postulates. You'd be wondering what the difference between axioms and postulates is. Well, in geometry, they are essentially interchangeable. The general meaning of postulate is a true statement. Let's have a look at what the first postulate says. It states that a straight line may be drawn from any one point to any other point. To understand this, suppose we have 2 points A and B separated by a distance. Now, if we want to join them, we see that we can draw only one straight line that will connect the both of them. We can take the help of Euclid's axiom that states, given 2 distinct points, there is a unique line passing through them. So a line from A joining B is AB. Similarly, the line joining A from B is also AB. The second postulate states that a terminated line can be produced indefinitely. By terminated line, we understand that it's a line segment. This postulate means that if we have a line segment AB, we can extend both its ends endlessly. What about the next postulate? The third postulate says that a circle can be drawn with any center and any radius. This postulate is self-explanatory, but for our understanding, let's assume a line segment AB. Keep point A fixed and move point B around point A. We will see that it will make a circle, and the length of the line segment AB will be the radius of the circle. Likewise, we can draw a circle from any point and with any radius. The fourth postulate says that all right angles are equal to one another. Look at the square and a rectangle. We see that all the interior angles of the rectangle and the square are right angles. Therefore, an angle from a square will be equal to an angle from a rectangle. So, these are the Euclid's first 4 postulates that will help us having a better understanding of geometry.
5. If a straight line falling on 2 straight lines makes the interior angles on the same side of it taken together less than the 2 right angles, then the 2 straight lines, if produced indefinitely, meet on that side on which the sum of angles is less than 2 right angles.